In this video, we're going to be talking about getting your Fulcro app working with the server. So we're going to start first with modifying our deps. So we've got our application running. Basically, at the end of the last video, it's doing what was there. And I'm going to go through adding some things and changing some things to get us ready for full stack. So the first thing I need to do is add a few things. So if you remember when we're running Shadow CLJS, it starts a development server. I've told it to start it on port 8000, and it'll serve things for us there so we can do our development. And when I start to run a server myself, in order to serve the HTML and then API requests, I want to serve this same resources folder. So I want to make sure that resources is one of my paths. And typically those resources also need to be deployed with your application. So having this be on the class path when you use something like depstar or something to generate an Uber jar is a good idea. And then we're going to need a few things to provide the server side of things. So we're going to use Ring. I'm just going to grab the latest version of Ring Core. We'll use HTTP-Kit for the web server implementation. We're going to use pathom to provide the query processing mechanics for the back end. This basically lets you adapt any kind of database technology or just straight maps or whatever you have on your server to a query parsing engine. And then and then we're going to add these extra paths in dev mode to add a dev namespace, so we have a place where we can start and stop our web server. Just some helper functions that don't necessarily need to be in production. They wouldn't actually be built into the resulting final thing that we'd maybe deploy to AWS or whatever. So we're gonna add those. So by adding these extra paths, resources, dev, these dependencies, the deps tab over here, I can do my refresh and make sure that everything, make sure dev is checked first of all, or this dev path won't end up on there. And then I'm going to make a top level directory called dev with username namespace user. I think we already had resources public index. That's the same index file that you saw before. Nothing different there. I am going to add semantic UI, semantic CSS. So we did that in the last video. Sorry. I think we're already rendering that. I did add that to the HTML just so we'd have a little prettier UI experience while we were working, more for aesthetics than anything else, and to demonstrate how you use classes easily with the DOM. So let's just jump right into how to build the server. So you'll see that the server code is really pretty tight. It's less than 35 lines of code, and actually the server itself, the middleware, is lines 27 through 34. That's really all you need for the server processing, but then you need something to parse the queries, and so that's where this pathom parser comes in. And so I'm going to leave this set up to you reading the documentation of pathom. This is a decent start to setting up a pathom parser, and it's going to give us all the functionality we need for these demos, but it's quite a detailed, involved, feature-rich library that makes our lives much easier when processing EQL, the Eden query language that Fulcro uses for its queries. Okay, so most of these things are Ring things: wrap not modified, wrap content type, wrap resources, the thing that goes looking on the class path for this folder, and then we'll serve anything out of it. So resources happens to be on the class path. That's what the blue means, and that's over here in deps what paths and extra paths mean. It means add these paths to my class path. That's what deps is about. It's about building a class path for the Java JVM. So that gets me my basic service, and of course, since this is Ring, you thread it top down, but it runs bottom up. So requests are going to come in, they're going to hit these things, slowly move through adding features, and then if something decides to satisfy the request, like wrap resource, it can do the response right there and short circuit the rest of the chain. Wrap API is a function defined in Fulcro's API middleware namespace. And also there's a convenience not found handler there that's just really a trivial 404 invalid request kind of thing for convenience. But you can use your own additions to the chain. The wrap API does need you to use these Fulcro middleware transit params and response pieces that do the transit on the wire encoding and decoding for talking to the client using the extensible transit protocol. So essentially Eden on the wire. Transit itself encodes Eden as a deduped JSON, so it's actually meant to be, super fast in terms of CPU processing, etc. So that's all you have to set up for the server. Again, this code ends up checked into GitHub, so you can take a look at that after you've watched the video or while you're watching the video. Okay, so now that we've got our server set up there, we need to add a build configuration up here for Clojure. So I'm going to add a local Clojure Repple this time. So this is going to ask me various questions here. And really, I don't need to change anything in Repple's fine. We'll call it CLJ. Make sure the module says the module. Sometimes this doesn't get selected if you've got some. Typically it does. So probably not a problem. Shouldn't need anything else. You can apply that, OK it, hit go. And assuming you've got the right Clojure depth selected here, assuming the dev is selected, that's really important. Otherwise, your user namespace won't be on the class path and you won't be able to get to this stuff. Then we'll be able to go talk about what's over here. Okay, so it's started. I'm going to tell it to load this namespace, and I'm going to show you my key map here real quick. There we go. So I'm just going to go to there, clear that, and then open those. So I've got a keyboard structure. I set mine to Control-C, Control-L. That means load the file I'm on into the REPL. These default to something, but you should probably have at least that one and the one that tells it to switch the REPL to the current namespace. I use Control-C, Control-N for that. So that's essentially what I'm doing here. Is well, I don't have to do the Control-C, Control-N because the REPL starts in the user namespace, so it's already going to be here. But Control-C, Control-L, well, you can see it loads the namespace there. And then I've actually gone in, if you do that, find action in the IDE, Command-Shift-A, and add REPL command, you can actually add, some new command to run in the REPL that you can then tie to a keyboard shortcut. And I've already got several added, so instead I'm going to go to Edit REPL Commands, and you're going to see I've got one called Restart User Namespace, and so I just label it that. I tell it to execute the function restart and then execute that in the user namespace. So it's as simple as that, and then back in the settings, I've been hitting the keyboard shortcut for this command comma. I'm going to the key map, and I can actually look for these REPL commands. You can see I've got this one for restart user namespace tied to Control-C, Control-G for like a go. Make the thing go. So you'll see me occasionally restarting things, and basically I'm just hitting that keyboard shortcut, and you'll see restart appear down here along with the I'm reloading code, etc. So let's talk about how that works. So the HTTP kit server gives you a run server command. You give it the middleware, which we were just looking at. It's just that stack of Ring middleware functions, and at least the port you want to run on. So I'm going to choose 3000. I'm going to log a message, and then I'm going to place in this atom whatever that returns, because this returns a function that can stop the server. So when you listen on an HTTP port or a TCP port in general, and a process, that's a operating system level resource. You have to be careful not to leave that thing allocated. So when you go to reload code in the JVM, you can reload the code, but if you lose access to that operating system resource, you'll have to completely quit your REPL and restart it to let go of that operating system resource. So what we want to do is set up a sequence here. This is like the, if you ever watched Stuart Sierra's Component Reloaded, one of his talks about that. It's essentially that. You want to make sure that anything that's stateful in your server is cleanly shut down and started up. Now we're not going to use component. These days I tend to use mount, but either way, having something that can manage your stateful resources is a great idea. All we've got an HTTP server, so it's pretty easy just to manage it in an atom. So that's what we're going to do. We're going to throw it in an atom, and really all we're going to store there is the stop function. And then for restart, well, let's look at stop. Stop's going to check to make sure it's started, and if it is started, it's going to call, right? It's reading the function out of the atom and then calling it to make sure it's stopped. And then we've also added another thing to deps that I forgot to mention, and that's this tools namespace library. This library has the code you need to unload namespaces when you refresh them, which is sometimes necessary for clean, full, like refresh of the code in your Repple. And so that's why that dep is there, and we've required it here. 2 steps here you need to make sure you do. One is, this one's pretty important. Set your refresh ders to just the directories you want reload to check. Typically you do not want this checking resources, which it will by default because it's on the class path, and you typically don't want it checking, you know, other things that it might, you know, it might find on the class path for potential refresh. So this is important because the clojure script compilation phase can put out files that look like files that it might want to use, and so if you have the refresh ders unset, it might find things and refresh them and bring them in that just confuse things like crazy. So make sure you set these or you'll have a really bad time. So then all we have to do is, after we've stopped everything and made sure we've let go of the OS resources, we can call refresh, and then we tell it, after it unloads and reloads all the namespaces, go and run this function, which happens to be here, but the reason you give it a symbol, a fully qualified coded symbol, is that during this refresh it will actually unload the user namespace and recreate a var. And so if we had handed start here as the value of a var, it would be the old start, it wouldn't be the new start. And so if we had, for example, changed the port or whatever, it would get the old start, and the old start might be tied to old state, etc., etc. So that's why it takes a symbol. So this is very boilerplatey. If you've started with the Fulcro template, all this stuff's kind of already set out for you. But since we're kind of coding this from hand and seeing kind of the bare minimum, this is what you typically set up as a bare minimum. So that's in the user namespace, and like I said, I set up a keyboard shortcut, and so anytime you see down here as I'm going through the demo that happen, I just hit a keyboard shortcut to do that. So I can be in, you know, in some file over here messing with things and say, oh, I want to try that. Oh no, I modified that. Let's restart. You know, so there is no automatic hot code reload on the server. You have to trigger it once you're ready with the changes. Okay, so we've got our server. Now what do we have to do to make the client talk to this server? Well, it's really quite simple. We go over into our client, we find where we defined the app, we find the Fulcro app function, and we add a map of remotes. So remotes is the option. It used to be called networking. I may add an alias for that just so porting is a little easier, but nah, I don't tend to like aliases. So anyway, you say remotes, and then you name your remotes a keyword. You can have as many remotes as you want, and there's a built-in remote implementation for talking to HTTP, and there's an add-on library for WebSockets, Fulcro-WebSockets in the Fulcro Logic GitHub group, organization, whichever. So this guy defaults to contacting the server that the web page was loaded from at the /API endpoint. And if you look back at our server definition, we've told our API to listen to the /API endpoint. So remember, what we're sending from the client is a full query. It tells the server everything it needs. There really only needs to be one contact endpoint. This isn't REST. This is send a query to the server, query gets answered by the server via a parser. So that's all there is to make the client be capable of doing full stack operations. So pretty straightforward. And this, of course, has all sorts of options you can add in. You can add in extra middleware. You can extend the transit encodings. So if you have, say, maybe you have some particular data structure you want to encode, I don't know, geocoded data into or something, and you want to carry that over transit, you can add transit handlers on both sides and actually have that be a supported data type on the wire. Transit's really nice in that it already knows how to encode big decimal, it already knows how to encode dates, etc. And so what I recommend most people doing, if you're going to use, say, monetary units, let the big decimal come across. Now, unfortunately, JavaScript or ClojureScript doesn't directly support big decimal. It brings them in as this tagged representation, but it's not hard at all to grab like a JavaScript library like big.js that implements big decimals in JavaScript and simply wrap some you know, make yourself a little math library that makes those truly isomorphic on the clojure script side syntactically. So for example, on one of my projects we have a math namespace where it's got you import it, alias it as m, and then it's got like m greater than and m plus and etc. Where you can combine, you can mix and match things, and it gives back big decimals, and then you can keep in state the big decimal the whole time through. And so your state on the client is always big decimals, your state on the server is always big decimals, your state on the wire is big decimals, and then all you have to do is just adapt your UI inputs to make sure that they understand that, okay, it's a string when it's talking to the DOM, but when I get the string back, it goes back in the big decimal, that sort of thing. So I kind of highly recommend don't make your types different amongst these two sides. You've got the same language on both sides. Yes, there are some differences. Big decimal is one of them. Make it work. In terms of dates and times, there's a new library that's in alpha called Tick from Juxt that looks to be, we're already using it in a couple of projects. Kind of standardizes the way of using time. You know, full stack works in Clojure, works in ClojureScript, works the same way. Wraps, you know, the Java time things, gets you down to instance, which is usually what databases want to persist. I just highly recommend get it all in one thing. Don't be trying to convert these things on the fly like you're doing JavaScript. Don't do that. There's much nicer ways of doing it. Okay, so we've got it set up. Now let's start talking about a few more things. There's a lot of little concepts in this particular video. If all you wanted to know is how to make it hook up, we're done. The rest of this video is really talking through some of the kind of best practices and other things, and actually seeing it work, like seeing some API calls, do some loads, etc. Okay, so we've got our Repple running. We're on port 3000. It's time to play with Fulcro Inspect. So let's clear this out. We can see that there was data we already normalized with this initial state stuff. So let's go through here and just say, you know what, our person list is just empty. There are no people in our person list, and we're just going to start ignoring our initial state for person because they have no initial state, and cars because they have no initial state. On the first render, I don't know who the people are, and I don't know what cars they own. I got to ask the server for that. And then I think we do have a make older mutation declared here, but I think I've currently deleted it. So I think, yeah, it doesn't seem to be there, and I don't think I declared it in any other place, so I must have dropped it, but that's fine. So let's just take that out because that was, or I don't know, let's leave it in and we'll remake it and make it a full stack thing. Okay, so I'm going to start splitting things apart into, oh, I did put make older over here. I started to. Data model. Okay, now you'll notice my model files here, car and person, are CLJC files. You can do this in a number of ways, and I'm sort of just kind of going to play through the options you have here. You could make completely, I don't know, you could jam everything into one namespace. That's one way of doing things. I don't tend to like very large namespaces for a couple of reasons. One, anytime you change them, they themselves take a long time to compile because they're large, and the larger they get, the more things tend to depend on them. And so when you change it, you get this like tree of things that has to be recompiled because the compiler can't easily tell what did and didn't get affected. And so you get kind of largish incremental builds. So in terms of scalability, I recommend small, concise namespaces. That's part of the reason why Fulcro has been broken apart from version 2 to 3 into you know, a fairly large number of namespaces where each one has, you know, a specific purpose. So that's kind of a thing I've come to the conclusion on working in Clojure for years. I just like smaller namespaces. Now, what you could do is we're going to start talking about a data model where we have a full stack data model. And so that's really kind of the subtopic that I'm talking about here. So I've got people and I've got cars. And those things might need Clojure specs. I might want to spec them. They might need particular ways of accessing them so I can get from the server to the client. That's what these resolvers are. We'll talk about those in just a moment. And I might want to co-locate, at least in namespace name, the clojure script version and the clojure version in kind of the same logical named place. And the reason for that, if you remember over here, make older, this is a namespaced thing. Even though it's a piece of data, your mutations aren't all top level simple names. That would be horrific, right? Scalability wouldn't be great. This is really something like, well, in this case it might be app model make older, or app model person make older, right? That's the actual mutation symbol that I'd want to send in order to invoke something in that namespace. And so what I could do is I could create a clojure script namespace called person, and I could have a person CLJ, right? I could have two different namespaces and put the server-side stuff in one file and the client-side stuff in a different file. The problem then is a CLJC file, if I remember correctly, a CLJC file can't also be there. You can't have all three. So if you really want there to be both kinds of languages with the same name, you either have to do them as purely separate files or one CLJC file. And one CLJC file is convenient because there are some things that you'll want in both. So for example, specs. I might want the specs for ID, name, age, and the actual full model of the person to be specs that I can access on the clojure script side and the clojure side, and have those for instrumenting, testing functions, enforcing contracts, etc., whatever I might need them for. Those I'd like to share. However, maybe my database on the server and my resolvers on the server, well, those are just clojure code. And so making a CLJC file, you do these conditional statements that indicate, okay, this is just for the clojure side. And so, it looks a little messy. And, when you get down to the mutation, you end up doing something like, okay, on the CLJC side, it looks like that thing, and in the CLJS side, it's this other def mutation that has the same name. And now you can argue that, oh, well, now I'm mixing, client code with server code. And that's true. That's absolutely true, and it's a good argument for making them separate namespaces and potentially choosing another namespace for just the pure model. Right? So there are a bunch of ways you can do this. I'm going to, for convenience and compactness in this talk, probably keep them all in this single file. But I just wanted you to know that some of this is going to be like a best practice, and some of this, there are trade-offs, right? So if I were doing this as a best practice, I might just put the specs in a namespace of their own that was just for the specs. That's all that went in there was the specs. And then choose a similar namespace, maybe in a slightly different package for dealing with the operations and the resolution of those things. So right, I might make an app specs and then make a namespace called person that's CLJC, and then in here do that. Well, no, let's do that. And so then that gets me into something where I can convert this to clojure, which is mostly what that particular file was already, where I can raise these up and get rid of this extra cruft. That's probably more the best practice way of doing this particular thing, so I didn't end up mixing and matching my client and server code in the same file, even though from a namespace perspective, I might want to put a clojure script file called person in this same directory with my specific documentation for the client. Okay, so let's talk namespacing for a second. So I've gone over here and I've made this spec. I'm going to do the same thing for CLJC file for car, and I'm going to do the same sort of require, and that's all that's going to go in here. And then maybe over in car, I don't think I had any specs, but now we can convert this to a CLJ file, splice that, splice that, splice that. Okay. Now I'm creating these namespaces primarily for specs and to give a distinct name to anything that I do spec. So let's talk about this for a second. So if I look at that : field, I think we mentioned this in an earlier one, and as a Clojure programmer you should know this like the back of your hand. : puts the current namespace's namespace name and is the namespace of the keyword. Something that a lot of people are doing, including me in documentation for Clarity, and I've seen it in Datomic docs, etc., is the thing you've seen already in many of these videos where we'll name an attribute something that's just sort of like entity and an attribute. The problem that you're probably going to run into, or possibly going to run into, and I sort of consider this like a potential looming cancer for Clojure, is if you make a simple keyword like this, the design of specs is such that this def registers this keyword into a global registry. And that global registry has the semantics, and the documentation of specs says this, you just have to read carefully. It has the semantic of RDF. It has the semantic of this is a global name that other people could easily collide with. Make sure you use something that you own. Right? So this goes back to the old Java standard of you name things with a namespace you own, you know, com.fulcrologic. I own that domain name. Any name in here is one I create and control. It's a federated namespace. The federation is I own that one, you own some other one, somebody else owns another one, and we don't want to stomp on each other. If I start injecting person ID into this global registry, well then I might load some library that does the same thing unbeknownst to me, but maybe they say, oh well, this is a positive int, or this is a UUID, or this is a, right? And now I'm in trouble, because now some library has infected me with a spec I didn't expect, and now stuff starts acting behaviorally. Maybe my generative tests crash, and I'm scratching my head about it. So you really want to generate globally unique names as much as possible, and I'm still, you know, in this particular application because I've chosen app specs. You know, app is my top level. I don't own that, right? I'm being lazy here, and I'm admitting it, but I am making a point of if you're going to use specs to try to get some sort of data enforcement, and I highly recommend you do, and there's a lot of great libraries coming out. I use Ghostwheel pretty heavily for some notational convenience around this, and some other production time conveniences and development time conveniences. These are useful. They give you back some of the things that you've lost by dropping a type system without giving you the constraints of a type system. So I do highly recommend them. I highly recommend that you learn how to use them, but if you are going to use them, be careful that you name them well. Okay, so get off my soapbox about that and get back to coding. So let's talk about resolvers. Now my server, I've set up this pathom parser, and I'm using connect, which is the main sub-library, if you will, of pathom that lets you register resolvers. And resolvers here you can see is just an array, and this array contains subarrays. So it's just like an array of arrays of arrays of arrays of however deep you want to go that eventually get you to resolvers. And so instead of using a multi-method where you kind of you have to require the namespace and make sure you've, you know, etc., etc., this makes it very explicit, and this also makes it possible for you to define multiple parsers in the same server side that can answer different kinds of questions. So this is kind of the preferred way of building these. You certainly can write a macro that auto-registers these. I've certainly done that in some projects. So I just want to show you there's one way of doing it here. Okay, but there's more than one way of doing it. So how does this work? Pathom's actually pretty straightforward, and it's got some really great yet simple ideas. So let's go look at the person resolver. I've created a table in here that looks a bit more like what I'd see in a database like Datomic or even SQL, right? You've got some table, and in this case I'm indexed by ID, sort of like I do on the Fulcro client side. But instead of these being idents, these are just like, you know, foreign key references. Cars, well, it's going to be car with ID 2. Cars, it's going to be car with ID 1, and these are just sets. This is sort of how Datomic does it. So if I go look at my cars model, you see I've got a table over here that says, oh, well, car 1 is a Honda Accord, car 2 is a Ford F-150. Okay. Now, we get to some interesting things here. If we go over to the Query tab of Fulcro Inspect, and we press this little gray button here, well, it should turn green. Maybe I didn't reload it after I... there we go. Once it turns green, it's actually loaded the indexes according to what these resolvers have spelled out for it. And so let me show you what that means. When I define a resolver for car resolver, I can say that I expect as input a app model car /ID, and I can output the ID, make, and model of that car, and then the code to do that. So in this case, this could be an SQL query, this could be an Atomic query, this could be whatever. This just needs to fulfill this promise given the incoming parameter, which will be there because I said that this input's required. So pathom will figure out how to get you the input if it can. It'll pass it to you as a param, and then you have to satisfy the contract of outputting that stuff. Once you've defined that resolver, then you can go over here and say, well, I want a join on app.model car /ID1, and I want app.model make. And I got a not found. Why did I get a not found? Oh, because I moved I moved everything and didn't reload the code. Let me reload stuff over here. Query, load the indexes. Oh, okay. So now I've got, I think after I've talked about all these keywords, I think just for clarity and quickness here, what I've done is I've moved, this was an off-the-cuff kind of thing I did here, creating these as a demo, and now my namespaces don't match what I've defined in the resolvers up front. So I think what I'm going to do is just say, let's not talk about specs for the moment. Let's just simplify the namespaces. Let's do the simple thing for demo purposes so we don't waste a lot of time on points that have already been made. Talk about all these pieces in just a second. They're actually pretty easy. Okay, restarting the server, reloading the code over here, going to the query tab, loading my indexes, and now I should see car. Why am I not getting? Definitely should be seeing that one. So the way the def resolver works is you tell it what the inputs are. I think I'm going to just stop this and restart it just in case I've screwed up my hot code reload. You can specify what input you expect, And this goes back to over here in the UI when we defined, wrong UI, client. When we defined car, remember we had this ident notation of, well, the table name is going to match the ID name. And the reason for that is if you do a query, a join, whose join key is an ident, car ID 1, and whose subquery is like what you want out of that car. That's what you're seeing me do over on the right. Pathom can automatically establish that if you're joining on an ident, it knows you want to start with car ID set to 1. So it already knows a car ID. That means it can go looking for resolvers, like this guy, that says it can take a car ID. And then the declaration of what it outputs, it can use to figure out if this particular resolver can resolve the thing that you're asking for. And in this particular case, we're getting some sort of error. Okay, lesson number 1, talk on the right port. So I was talking to Shadow CLJS here. I need to be on 3000, which is where I started my real server, and I didn't give it a default page, so I'm actually going to have to say index.html. Now I'm loading from the correct server. That helps. Okay, so you can't ask queries of a server that doesn't know what you mean. So that explains why this was turning yellow the first time. I'm not sure why it turned green ever. But now I should see, there we go. So I can ask for a car ID 1, and then I can ask for car make there, I can ask for car model, I can run that, and I get back Honda Accord. I can ask for car 2, F-150 Ford. Okay, so there's your first resolver. So now, as promised, not demonstrated until now, but as promised, this little bit of code here with an SQL query, a Datomic query, a MongoDB query, whatever database you're using, just needs to know how to get from a car ID to these other facts, and it can resolve that layer. Now, the next cool piece is over here in the person side. So in the person side, I've got the same sort of thing for the person resolver. I say the input is person ID, and from that I can get person name. I should also say I can get person's age. If you don't declare this here, it doesn't mean you can't return it. It means that it won't show up in the autocomplete over here in the tool. So this PC output is very much about it's about a combination of it's mostly about autocomplete. But notice here for the cars, I'm not saying what other things are in a car, because this resolver doesn't resolve that. All it does is resolve the joins. And so the code of this is saying, if you give me a person ID, I can give you the name, I can give you the age, I can give you their car IDs, but that's it. And actually it's allowed to resolve more than that. But if you look at the implementation here, I'm taking all of the people, which is this database, I'm getting the one they asked for, and then I'm updating the cars field, which is a set, and taking that set of IDs in and returning a vector of things that look like a map of car IDs. So I'm basically building a map that matches what I'm asking for. So now over here I can ask for person ID 2 person/name, and then I can ask for a join on person cars, and then it should already know that I can ask for car make. And then of course person name Sally, so Sally has a Honda. Sally has car 1, and car 1 sure enough is a Honda. Okay, so that's how we can join things together and have pathom build the graph for us. There are a number of other features in pathom. I'm not going to cover them in this video. Let's go ahead and get a full stack mutation going here just for giggles. Now for that to work, our database has to be modifiable. So let's move our database table over into an atom. So this is a root level resolver. Let me go ahead and finish fixing this to be a writable database. Restart the server, rerun a query, still looks the same. Person resolver. So if you say that no input is needed, like this one said person ID is required, here we said no input is required, but we can output a join of all people to the person IDs. So this creates a root level query, or a keyword based query, I guess would be maybe a better way of seeing it. So I can ask for all people because nothing's required to get there, and so pathom knows how to start that, and so it knows that person ID is a thing I can ask for there. And you see person ID 1 and 2, and the other resolver says, well, if you have a person ID, then person name is obtainable. And I'm not getting a resolution there. I'll have to fix that. Did I do that right? All people. Oh, I need to join. That's why it's not working. There we go. That's why the completion wasn't working either. There we go. So a join on all people to the subquery, and then of course I can do a join on person cars to the car make, and we can see that Sally owns a Honda and Bob has a Ford. Okay, so this is kind of your in GraphQL this would be called a root resolver. In EQL this is just a global resolver. Basically you can ask for this anywhere because it requires no context. So if I want to go down here and say, oh, and then I want all people again, and this time I want person, just person name, you can do that, and it'll be returned and nested inside of here. So that's another advantage that pathom, or that's an advantage pathom has over GraphQL. Because it is schemaless, it's perfectly fine to mix and match global resolvers wherever you happen to need them, and so there's no need to have a root at the root. This also lets you do things. This is a really nice feature. Let's say you needed to know if your client's time was the same as your server's time, right? You could say the output is the fact server time, and so then you're going to return server time as Java util date, which is an instant. Transit can handle that. We're going to add that to the resolvers that are supported. Restart the server, and then anywhere in here, what did I call it? Server time. Oh, not found. Why is it not found? Output is server time. I output server time with the date. I put current system time into the list of resolvers. Interesting, the completion is telling it to me now, but I have mismatched this. Oh, let's actually make things match. There we go. So now I'm getting the server time as an instant, and I can mix that anywhere I want. So if I had, back to our join where I had all people, and I had person, say age this time, I could just mix server time in there and get the server time at that layer. So these global resolvers are particularly handy since Fulcro gives you normalization. Being able to grab things at any place in your query tree is quite handy because it just doesn't matter. It doesn't matter if they're nested somewhere in the query because you're normalizing them at the end of the day. Okay, so now that we've got, I'll just leave that resolver there. It's not hurting anything. Now that we've got a way of resolving these things, and we've kind of tested out the query engine and see that it seems to be working right, we should be able to populate our client when it starts. So over here we're going to say on init, see now init's getting called every time the client remounts, so we probably don't want to do it there. So instead we can go into here. So client did mount is just a callback function that gets called once and only once on the real mount of the application. And so in earlier videos we saw merge component, and there's another function in the data fetch namespace which I just required. And this data fetch namespace has load, and it takes very similar parameters to merge component, except it wants to build a query for you. And so here we're going to ask for all people, because we know that and all the people are persons. So essentially I'm making a query that's a join on all people. That is the name of my resolver, right? All people with, so that's essentially what those two arguments combine together to do. If you make this nil, then you get just a prop query. And if you make this an ident, then you get that earlier person ID to join query. So any of these things could be done. So let's just start with this one. Let's say if we load person 2 on start, so I can reload, I can go and look at my database, and you should see person ID. I've got person 2. Now, of course, person 2 didn't get joined into the rest of the graph anywhere, so nothing showed up on my screen. But if I load all people here, knowing that they're persons, the server is going to return me a too many, so that will result in normalizing a too many thing over here. So now I should see 2 people, all the people in the database, and I should see a top level key called all people that has my 2 idents in it. Now, that's not where I wanted that edge, right? That ended up in the root because I queried it from the root with load, but the edge I really want to build in my graph is the person list people edge. But I know that one's at component ID person list people. So I can target it. So this is just like the merge component replace. So I want component ID person list person-list people. That's where I want that edge to go instead of in the root. So now when I reload, I get my people. Okay, so there's your first exposure to a full stack load, and you can see it's just almost identical to merge component. You're just telling it how to find the data, and in merge component you're actually handing it the data. And pathom resolvers, if you look at the Fulcro inspect network tab, you can see that it queried for a join on all people and then specifically what the component and subcomponents asked for. Right? Now if I go and do some refactoring my code and decide, you know what, I don't want to show how old they are, I'm going to take age out of the query, I'm going to take age out of the UI, I'm going to reload, you'll see that the network tab here then sends a query that doesn't have age in it. And of course, still normalizes it, still puts it in the database in the right place, but reduces your overall network query load. So that's always been one of our big intentions, is to get that kind of data flow in, normalization, working consistently across all possible ways we deal with this data. All right, last thing, we said we were going to do the mutation. So let's go into person CLJS and let's finish recoding this. So here before, if you remember, we had person keys ID. We were going to pass in person ID, and then we were going to update in person ID, person age, and we were going to increment. Right? That's the make older mutation. Back in the client, now we need to get app model and now make older no longer needs quoting or unquoting. Remember this function, if we call it directly in a, I'm not in a clojure script REPL, let's start the clojure script REPL one. If I actually run that function, as it will here, it just returns itself as data. And so then that's what's going to be submitted to transact. Transact's going to push it through the processing system and actually run it. So at the moment, if we look at our transactions and we say make older, we see it's making this person older, but on the network nothing's happening because that's not a full stack mutation yet. Now we do have on the server side, that's client side, this is server side, we do have a mutation I've already started to put in here, and in here, same thing, it's gonna, we want the same parameter, but in here the code is just a little different. So the code here is going to be a swap on the people database, and it's going to be very similar actually. It's going to be an update in at ID person age So it's very similar because the database is very similar. And I'm going to return an empty map here. Be very careful about mutation return values because Fulcro does actually support return values from mutations. And so you don't want to return some arbitrary thing here that might not be serializable. So for example, what could I throw here that transit wouldn't like? There's got to be something. That one, I don't know if that implements an interface. Clonable, serializable. Yeah, that should screw it up. Go to the right REPL. Say go. Okay, so my implementation is right. I'm trying to show that the return value of this full stack, I'm mixing and matching things. Let's just hold off on that for a second. This would update my database over here. And you can see if I come up here in the REPL and look at this current database, I can see how old people are on the server. All I have to do to make this full stack is go to the client-side version of this, create a section that uses, the same name as I named it when I created the remote. So remote. If I had called this Bobble, then I would call this Bobble. Excuse me. But by convention, we just call the main remote. I don't need the env usually here. I can return true, I can return the env, I can return a number of other things to modify the outgoing network request, but true just says send the same thing to the server as the client processed locally in its transaction processing system. So literally send that data structure across the wire. Let's restart my server to get that implementation of the server-side mutation. Let's reload the client because we've modified the client's database to be different from the server. Let's look at the transactions tab, clear this, network tab is clear that. Let's hit make older, and we see locally it called the make older mutation, and before it was 22 and after it was 23. And if we look at the network tag, we see that same exact mutation as data was sent over the wire, triggered over here, and we didn't log anything, so we didn't see anything there, but we can go and see if we output this guy that Bob's age has changed to 23, and if we reload the page, Bob's age is still 23, as we would expect. The database changed. So we can pop this guy up to something like that, reload. We've now got a full stack mutation. So you can see that once we've got the server set up, things start to fall together pretty well. And it's pretty simple to implement things, especially since it has the same abstract representation on both the client and server in terms of it's just data. So let me go back to this particular point I was trying to make. If I do that, you see an error happen over here, and you see probably an error in the console here, internal server error. This is the kind of thing you want to kind of watch out for. So basically, if you read this carefully, transit write impl, oops, copy paste on drag and drop. I never understood that. It doesn't know how to encode bitset. Bitset isn't something that transit has built in. You could actually tell it how to encode bitset, but it doesn't currently know how. So if you accidentally return some garbage from some function call because you weren't thinking about what it returned, you can cause these mutations to crash. So be careful. What you put here. An empty map is fine. A keyword is a reasonable thing to do. Both those things are encodable. And interestingly, if you wanted to do something like have the pathom parser let them have a return value with a constructed subtree happen, you can return something like that from a mutation, and then if the client sends the mutation with a mutation joined query, the parser can follow from this mutation on to find a response that's different from whatever query you might have had to query for the thing to begin with. More advanced topic, but interesting to note. I think that's enough for this video. It's getting rather long, so we'll stop it here and continue with with a new one.